Hello everyone. So I welcome you to the lecture series on MCQ question answer explanation in artificial intelligence. And today's question will focus on two topics, that is Modus Tollens and Modus Ponens. This means with this question we try to understand what does it mean by or what is Modus Tollens and what is Modus Ponens. And these questions or this type of question is being frequently asked in UC NTA net examination set or this type of competitive examination. So I mean to say that Modus Tollens and Modus Ponens is very important for you. So let's start today's class. Question says that consider following two rules R1 and R2 in logical reasoning in artificial intelligence. R1 from alpha to beta. You know that alpha you can consider as a what? Superset of beta. This means alpha can imply beta. And this n alpha divided by inter beta is known as modus tollens. And R2 says yes, from alpha to beta, that is from alpha as a superset of beta, n negation of b divided by internegation of alpha is known as modus ponens. So questions actually saying that R1 is modus tollens and R2 is modus ponens. So options are A, R1 is correct, B, R2 is correct, C, both R1 and R2 correct, D, neither R1 nor R2 is correct. So to solve this question, you have to have clear idea on modus tollens and modus ponens. So let's discuss each of them with example. So first coming to modus ponens. The form of a modus ponens argument resembles a syllogism. You know, syllogism means with two premises and a conclusions. This means if P then Q, P exists, then therefore Q. Actually, what it tries to say that if P is implying Q, okay, it is given. Now, we see that P happens, means it is found that P is happening. Then due to the modus ponens rule, we will directly say that Q is also happening, right? There is no negation in front of them. I'm repeating it again that if P implies Q is given, and also it is given that P is happening, then this means according to modus ponens is that Q is also happening, right? That is modus ponens rules. Now in question, you will find the rule to be framed in a different form, but ultimately the idea is same. So here the first premise is a conditional if-then claim, namely that P implies Q, that I have explained it now. The second premise is an assertion that P, the antecedent of the conditional claim, is the case. So this P is happening, obviously this is antecedent and this is what? Consequence, right? And it is found that antecedent is given or antecedent is the case that is happening. Then from these two premises, we can logically conclude that Q, that is the consequence, is also is the happening or conditional claim. Means this must be happening as well, right? That is modus ponens. Now, if I would like to give you a real example of modus ponens, then that will be, say, if today is Tuesday and then John will go to the work. Means if today is Tuesday, then John will go to the work. And again, it is given antecedent part is what? This is the antecedent part. If today is Tuesday and consequent part is then John will go to the work. Now antecedent is the case here, that is today is Tuesday. So due to modus ponens, we can say that therefore John will go to work. Got it? This is the antecedent part. This is the consequence part, and given antecedent part is happening. So as per the Modus Ponens rule is concerned, the consequent is happening also. That is therefore John will go to the work. So with this example, I hope that the concept of Modus Ponens is now very, very clear to you. Now coming to Modus Tollens. So Modus Tollens is what? The form of a Modus Tollens resembles a syllogism with two premises and a conclusion. Similarly, if P then Q, now you know this is the consequence part and this is the antecedent part, right? Now here what? Not Q means this consequence is not happening. Then the antecedent part is also not the case or also not happening. So if I write it in symbolic form, that is P implies Q, it is given, and also given that negation of Q. Q is not happening. Then due to the Modus Tollens, means according to the Modus Tollens rule, we can claim that P is, that is antecedent part, is also not the case here. Is also not happening here. This is the Modus Tollens rule. See here the negation is concerned. Means in case of Modus Tollens, you will find this negation. But in case of Modus Ponens, there is no such negation. Right? So let's take an example to understand this topic better. So the example is, if the dog detects an intruder, then dog will bark. So this means what? If the dog detects an intruder, this is what? This is the given what? This is the if part. Okay. That is the antecedent part. And the dog will bark. The dog will bark. That is the what? Consequence part. Right. Here consequence part is the dog will bark, and the antecedent part is if the dog detects an intruder. Now, what is happening is that the consequence part is not happening. That is, the dog did not bark. That is negation of Q, right? P implies Q and negation of Q is given. So with the help of Modus Tollens, what I can say, not P. Got it? With the help of Modus Tollens, what I can say, not P. So if you try to resample this with this example, then what would happen? See, the dog did not bark, that is negation of Q. So we can say the dog did not detect an intruder, right? The dog did not detect an intruder. So this means, therefore, no intruder was detected by dog. Is this clear to you? I hope now with these examples, you have a better understanding of what our Modus Tollens and Modus Ponens almost clear. Okay. So now I hope that this Modus Ponens and Modus Tollens, as this topic, this concept is clear to you. Now we can try to solve our given question. So let's move to the question again. Now, question is that R1 from alpha implies B and alpha divided by inter beta, then this is Modus Tollens. But you know that in case of Modus Tollens, what thing you have to focus is that there should be some negations, means that consequent parts is not happening, right? But this is not the case here. Inter beta is given, not what? Negation of beta is given. So this is of course wrong, right? This is wrong. Then from alpha implies beta and negation of beta divided by inter negation of alpha. And it is claimed that this is Modus Ponens. But you know in Modus Ponens, there should not be any negation. Means that antecedent part is happening. But this is not the case here, because here we have given negation of alpha. So this is also not true. So of course the option will be what? Answer will be what? Our D. Right? See, when you have an idea about this Modus Ponens and Modus Tollens, how easily you can solve this problem. But I already told you that the question may be framed in different form. it may not be directly asked, or it may sometimes be asked directly. So answer is D, and explanation is that the first R1 is actually the modus ponens, right? Modus ponens will be how? Because here this part, you observe that this is not related to negation, right? And modus tollens will be R2 only when this negation part is given. So with this, I hope that this modus ponens topic and modus tollens topic with this question and with these examples is clear to you, and that's enough for today. So now I'm going to sign out for today. So stay tuned. Dr. Dibbo will meet you in the next lecture. Till then, take care. Bye-bye.